TopSolid has exceptional functionalities for an in-situ design of a welded chassis. As a standard feature, we have a very rich library of sections of all types. We choose, for example, a square hollow section. We now position the components directly on the wireframe design drawing, choosing section justification. Then, by means of the attached assembly processes, we perform the straight or angled cuts, which may involve several parts. These cuts are played back in case of a change of geometry. These possibilities, which are general features of all components manipulated in TopSolid, are unique in the CAD market and offer incomparable productivity gains. We continue with the layout of a pulley subassembly that will be positioned on the chassis. TopSolid offers the most comprehensive layout possibilities in the market. Let us begin with the projections of the different views that can be imported from CD directly into the general layout already existing. We begin with standard linear, radius and diametric dimensions which can be positioned very easily with the mouse. We continue with composite dimensions which can be parallel, chained or cumulative, and finally we choose ordinate dimensions. These dimensions are adjusted automatically according to the space available. TopSolid has a local cross-section function which is particularly useful in this example. We can use any limiting contour which will of course be associated with the cross-section. Then we dimension the positions of the subassembly screws in a table. This dimensioning is particularly appreciated by mechanics who want to manufacture. Now we indicate the screws used on the main view and the associated drilling holes on the local cross-section view. To end, we produce the parts list for the subassembly by selecting the type of parts list we want to use. By means of an automatic referencing system, we automatically position the references, which are then marked in the table at our request. In a few moments, we have performed a labeling operation that was formerly dreaded by many designers. We end our example with assembling the pulley subassembly on the chassis. We begin by repeating by symmetry a subassembly already positioned and fastened to the chassis. Its assembly processes follow likewise. An in-situ design process enables us to create and position a shaft which will likewise be duplicated by symmetry. We then assemble the pulley subassembly taken from another document with automatic magnetizing and control of overturning by mouse with a mere click. The subassembly is duplicated by a double plane symmetry. We design and then position directly in the assembly a spacer from the library. Its length is calculated as the distance between two functional geometries and will follow their subsequent evolution. This is quite unique and a very useful feature of TopSolid, which enables a parameter to be calculated as a distance between any two geometries. TopSolid is the product you need to design a machine. Don't hesitate to contact our network of partners and consult our website at www.topsolid.com.